Using a series circuit from a previous example, we're going to take the values that we calculated in that particular video, and we're going to use the same amount of resistors, same values for each of these. We calculated the circuit current as being 0.34 amperes, and we're going to use one of the power formulas we talked about earlier using I squared R, which means that when we go to use this current, 0.34, plug it into the calculator and hit the square button. By squaring it, we come up with a value of 0.1156, and to use this easily, you can actually take this and just put it into your calculator and take a look and see, what we'd, how you can use this more easily. So we'll take the 0.34, I'm going to square it, I'm going to come up with 0.1156. When we take this part right here, the 0.1156, and multiply that times 10, which is our 10 ohm resistor, we should come up with 1.156, and this power is actually going to be in watts. Let's take a look at another resistor. This next one is a 12 ohm resistor. It's in series with R1 and R3, and it has a 12 ohm resistance to it. Let's take our current and square it back to the, we're going to recall that, 0.1156. It's a squared value of 0.34, and we're going to multiply that times 12 ohms times 112. This one we're going to get 1.38 watts. So each one of these so far, this is dissipating 1.156 watts. This one is dissipating 1.38 watts. Keep that on your chart as you go down through it. And let's calculate the power of this last one. So the 22 ohm resistor, it has the same amount of current flowing through it because the current through a series circuit is the same. So as we take a look at this, we're going to recall our 0.1156. I'm going to take that times 22. This gives us 2.54 watts. To calculate the total amount of power in this series circuit, all we have to do is add all three of these together to get P sub T for this entire circuit. So in the case of this, we're going to take 1.156 plus 1.38 plus 2.54, and we get 5.06. This is the total amount of power that these resistors are going to dissipate in the form of heat. This is the total amount of power dissipation. So we could also say that this circuit is actually dissipating as well as consuming 5.06 watts